Hello everyone. Welcome to another tutorial session on chaos engineering. My name is Shashank and I'm a senior technical program manager here at Harness, responsible for driving chaos engineering. In today's tutorial video, we would be talking about some of the high impacting scenarios that we have seen our other customers practice and how they are forming those experiments. So for today's session, we'll be focusing on how you can target zonal failures, how you can target regional failures. And when we talk about these two experiments, we will also talk about how you can control the blast radius using a different set of experiment for that. And we will also talk about like how you can simulate SSL and TLS certificates expiration scenarios using harness as well. Now, having said that, I'll just quickly jump onto my screen and we'll just go into that demo. So before we go into how to set up the experiments, there is some standard concept that I would like to cover. So when you have set up your Kubernetes cluster on any cloud, whether it is EKS or AKS or GKE, uh, Kubernetes by itself puts a standard label which talks about the different zones or the region. And as you can see from my screen here, the standard Kubernetes label for zonal selection is topology.kubernetes.io/zone. So that is the key. And the standard label to select the region is topology.kubernetes.io/region. So this is the key for that. And just to go further, how you can get these labels is if you run this command kubectl get nodes --show -labels onto your Kubernetes cluster. This command will give you all the labels that are associated with the Kubernetes cluster, right? Now, why these labels are required, we will cover that as well. Having said that, now I will go back to the product. And for the sake of this demo, I'm going to go to my account settings and go to my Chaos Hub. So we'll be covering two personas here. So an admin persona who is designing the template for zonal failures and the user who will be consuming these templates. So now let's say that, as you can see, I have multiple Chaos Hub here. So let me go to the Kubernetes use case. And once I go there, I can see that I have one experiment template and currently it is there for pod delete. Okay. Now I would like to create an template for zonal or regional failures. So I will first write low blast radius. And I will explain that what I mean by that is, and we'll say zone/region. And you can also add a description here. So low blast radius means we will be using a pod network loss. Why? Because sometimes most of the times what we have seen is you will not have approval to do a node network loss, to bring down a node or to disconnect that node. So you can still go ahead and test these scenarios by using a pod network loss, and we will see further what kind of configurations are required for that. So once I click on next, I can go and select my fault template. So as you can see that for low blast radius, we have to use pod network loss. Okay. Now in the target application, if I want, I can fix it to deployment because I only want people to run chaos engineering only for deployment workload kinds. Namespace, I will make it as runtime input so the users can change based on their applications and the deployment name as well, right? Workload labels is optional. So if you provide a workload name, a workload label is not required. But if you want to give that, that is also fine. Now we'll go to the tune faults. By default, the chaos duration for this experiment is 60 seconds. But in general, a best practice when you are doing a zonal scenario is you should have this configuration somewhere between 180 to 240 seconds. So as a best practice, I'll just give it as 200 seconds. Network packet loss percentage is by default 100. You do not have to touch it. Now, since we are doing a zonal failure, the goal of zonal failure is whatever pods that are present in a particular zone, they all should be affected. So that's why pod affected percentage should be 100. Network interface by default, it is ETH0. 99% of the times that would be the case. And you can see there is another important parameter called node label, and that is where we will use the label that we talked about before going here. So I'm just going back to the documentation. Now, if I want to do a regional failure, right, I can use a regional label, or if I want to do a zonal failure, I can do a zonal label as well. Now, what we have seen, what you can do here is either you can make this as a runtime parameter, right? But if you do that, the next question would be how will your users know what kind of key value pair it should be? So as a best practice, I would suggest you fix this and let the users change it in their local copy. So what I'll do here is I will go and take this example for so this means that I am targeting all the pods which are part of US-East-1A availability zone, right? So I can go ahead and give this as an example so that my team can understand how the key value pair should be put, right? And I can go ahead and apply the changes. Now the template is ready. We'll go back to the Chaos Hub and to the Kubernetes, and I can see that now I have two experiment templates. If I look at the low blast radius, pod, zone or regional failures, users have to provide target namespace and workload names. Okay. So now the next question would be like how this experience will look like for an end user who is coming to a project. So the end user will go to their kiosk experimentation and then they will create it from a template, and then they will select the template that you have created. So for example, let's say they are selecting a template of low blast radius here, and here they will provide their infrastructure. So let me provide my environment first, and then I'll configure the infrastructure. Now, if you do import as a reference, then users won't be able to change. So the best practice here would be to use import as a copy. So once a user does import as a copy, you can see that now user has an option. They can come here and they can change this parameter. Let's say if instead of US East 1, let's say your availability zone was 2A. So at least users have a better understanding here on what parameters they need to put, and rest of the things goes as same. As you can see that there are two parameters which are input. So you go to your experiment input set, create an input set for each service. Now let's say that I have an Nginx, right? And I will create the input set for that so that I do not have to worry. So I will go ahead and do that. And similarly, I will go and create one more input set, let's say for a encryption service, right? Now, let's say that this encryption service is also, let's say, in the same namespace, and then this could be an encryption deployment. So having said that, when you go and run this experiment, you can see that you can select from input set that you have saved, and you can choose those input sets and the value will come automatically, and that's how you can run an experiment. The takeaway from this important from this scenario is if you want to do a zonal failures, you can use a pod network loss for low blast radius. For high blast radius, we will use node network loss, and I will cover that. The important parameter here is the pod affected percentage should be 100, right? And the node label, as you can see, the node label is an important parameter. So as an admin, you can provide some value so that your users can change, or you can make this also as a runtime input, and then your team can change it on the fly. So with that, I will move to another version of this. Now, let's say you want to do a proper zonal failure where you want to bring down a node. And that is where the blast radius is very high. So we will go back to the Chaos Hub again, to the Kubernetes section, experiment templates. And now I will create a new template. And now let's name this as high blast radius, right? And let's say zone failure. I can add a description. High blast means for high blast, we will use node network loss. That means we will bring down the complete application, right? And these are the some of the things which you can use for disaster recovery scenarios as well. So just adding a fault template here, and here I will select node network loss. Now, node network loss doesn't have this concept of target application because we are targeting a complete node. As part of best practice, the best duration would be somewhere between 3 to 4 minutes. So let's give 200 seconds. Uh, Network loss percentage 100, we don't have to change it. Now, node affected percentage, right? Now, this is by default 0, but since you want to do a complete zonal or regional failure, you should make this to 100 and then node labels, the same concept. So you can copy your node label here, right? Instead of zone, you can also have a label for region, what we have seen here, right? So either you can target a complete region, right? You can test multi-regional use cases, or you can just target a zone, and we can test zonal scenarios as well. And you can apply the changes, and rest of the things remain same. Now for a user, which is who is part of that project, they can come here and create it from a template, and now this time they can target a high blast radius once you have the approval internally that you can run network loss scenarios. And I can select environment and an infrastructure, and then import as a local copy, because this will allow me to do the changes, right? And the concept remains the same. If a user wants, they can change the label, right? If their application is deployed on a different zone, and whatever, you can see that there is no concept of runtime here. I mean, you can always make it as runtime, but the reason here is since we are not worried about namespace or labels or the deployment names, because when it comes to node, it means we are targeting the complete node, right? So with this should be good enough to help you execute those scenarios. Now we will talk about another scenario here, which is on the, let's say, what if you want to target multiple zones, right? So currently with this experiment, you are targeting only single zone. Now, if you want to target a multiple zone failure, either you can come and add one more fault here, right? So how to do that? You come on the plus icon, and to add something in parallel, there is a control or command option. Now, since I'm on Mac, I'll press command and I will add one more fault, and we'll choose node network loss. Yes. And same concept, we'll go here and provide the parameters. Now, this time, instead of A, I will write it as B. That means now I am targeting both the zones at the same time, right? You can add one more thing in parallel, and you can target a complete cluster down as well. And the same thing you can do for a pod network loss. You can add something in parallel, right? So if I go to a low blast radius thing, I can come here and add a fault in parallel. I'll press command, and then we'll click here and we'll select a pod network loss again. Right, rest of the things I can make it as runtime. 200 seconds. Node label, I'll change this to B. Pod affected percentage should be 100. And that is how I can do a multiple zones. So that is how you can do these high impacting scenarios. The next scenario, what we will look at is how you can test your SSL or TLS certificates expiration scenario. Before we go there, I would like to just go back to the use case here, why this scenario is important. So most of the times your application does your application your client would be doing an HTTPS call, handshake with the third party service, or it could be internal service, and during that time your certificates do exchange. So the purpose of this scenario is to test, now let's say when your certificates expire, what happens to your complete application. So does your application throw a proper error code or error mechanism? I mean, do you have implemented a proper error mechanism? Does your application goes blank because suddenly an unexpected error has happened? And when your certificates expire, like, do you get any monitoring alert saying that, hey, this certificates has expired and we would have to go and renew? So these scenarios are becoming very popular in the chaos industry because certificates do expire most of the times. Okay. Now, to solve that to solve that problem, what Harness recommends and how you can achieve that is, I will go back to the Chaos Hub again, go to my Kubernetes, experiment templates, and this is for an admin view because an admin can come and create the templates. So let's say this is a template for SSL, TLS, certificates, expressions. I can come here and select, I can come here and select the experiment. Yeah, so I was saying to run those scenarios, we have to use a experiment called time chaos, and this is an admin view here. So in the workload kind, again, I can fix some of the things, rest of the things I can make it as runtime input and runtime input. And then in the tune faults, 200 seconds would give you the real value. And then there is this offset. So offset means is, so what happens behind the scene is when you run this experiment, Harness goes and changes the time of your container for this target application. So you are selecting an application, a deployment kind, and Harness will go and offset that time in the future, right? So let's say if I'm doing 36,000 seconds, that means these many seconds, right, I'm going into the future. And because of that, your certificates, it is a simulation where your certificates are expired and then you can measure the impact. So the pod affected percentage should be 100 here because we would like to test that once certificates expire, my all the replicas, it should expire for all the replicas. And this offset value, you can make this as runtime input so that the users can provide their offset. Let's say if they want to provide 1 year from now or 2 years from now, they can provide that and then measure the impact. So that is how you can create a template for SSL and TLS certificates expiration. Now going back to the end user. So end user who is part of the chaos experimentations, they come and they create this experiment from a template. They can select the template, select their infrastructure, and import as copy. And here the users can create input set, and this input set would be, let's say, in Unix. Offset, I want to give, let's say, 86,400 seconds. Namespace could be etc. Workload name could be, let's say, Nginx, and you can save it. Now there is so you can keep on saving these input sets, and then you can run these experiments. Now, when it comes to the best practice, what you can still do in this experiment and to reduce that cognitive overload is, rather than asking your users to fill this offset, which can be little overwhelming for them, they have to calculate for 2 years, what should I fill, right? What you can do is that you can go to your template and you can design your template in such a way that, okay, whatever happens, this experiment will go and change by default 2 years in the future, right? So 2 years in seconds. Uh, let me give hours would be better. So that is equal to 17,520 hours. Okay. So what I can do here is I can go to my template, edit this, and in the tune fault, rather than doing it as a runtime input, I can say that, okay, 17,000 something, yeah, 17,520 hours, right? And this will also, this will also make sense. Then your users just have to worry about their target application. Just one thing I wanted to call when it comes to this application, like I said, your target application should be making an HTTPS call to the server, right? Then only this experiment will work, because these certificates and handshake happens only for HTTPS call, not for HTTP calls. So now if you go and fix this template to, let's say, SSL TLS certificates expiration, and just going back to the chaos experimentation, as you can see, this has not changed because this is a local copy to you, and we are not using import as a reference. Okay. So either you can come here and change your local copy if you want to. So 1 minute. Uh, let's go to the tune fault. I can come here and change my local copy also. Right. And that is how you can save the your experiment. You can do whatever changes you want, and this will help you in executing those scenario. Now coming back to the documentation, if you go to developer.harness.io, and if you search here about time chaos, here you will find all the details what harness does. So time chaos is a Kubernetes pod that introduces control time offset. Right. And these are the use cases where TLS certificates expire. Right. And this is a mandatory tunable, which is offset. Right. And clock IDs by default, these are the clock IDs. And now just to give you another idea, like offset, it should match with either D, millisecond, second, minutes, or hours. So that's why I did 17,520H. So it's a very simple experiment to do the setup, and you can measure the impact, like how does your application perform. So this is what we have for today's session. Stay tuned for future sessions, and happy learning.